Today we're going to be learning how to solve volumes of revolution using both the programs Paint and 3D Grapher. Now, to really solve these problems, all you really need is a pencil and paper. That's mostly due to the math. The 3D Grapher will help us visualize what we're actually trying to solve. Now, for today's problem, we'll be using the disk method. Now, the disk method usually involves where you have no holes in the equation. And I'll show you what that means later on. Now, the two equations we will be using are y equals x squared and y equals 0. And we'll only go to a certain point of x. So we'll have from 0 to 2. Now, volumes of revolution equal the integration between some point A and some point B. And it's the integration of the area of the function of x dx. Now, it depends on what method that you use, depends on how you can solve for the area. For the disk method, using disk, volume equals the integration between A and B of pi r squared dr. Now, r just means radius, obviously. So when we have the revolution, the radius r will usually equal the function. So whatever the function is. So for here, since our function is x squared, the volume will equal, and x is between 0 and 2, 0 and 2, a, b. We have pi times the function squared, which is just x squared, so it's really x to the 4th dx. Now, you can move pi outside to here, and it really doesn't make a difference if you do. They both equal the same thing. But it's just also good to know that you can remove constants to make it easier on yourself for solving later. Now, this itself, bring down here, will equal x to the 5th over 5 times pi between 0 and 2. And what you basically do is you put the top number in first and then subtract it by the bottom number. So what you'll have is 32 pi minus 0. So the answer for this particular problem is 32 pi over 5. Good? Alright, but in order to, that's the good way to kind of do the work, but to really visualize it, we'll be going to this program called 3D Grapher. Now, the viewpoint you have here looks 2D, and it actually is. But if you click this button here, you'll see that you have a 3D graph. Now, in order to plug in points, so for now we'll plug in the function, we'll have to use u, v, and t as the variables, mostly because x, y, and z are preoccupied at the moment. So for whatever equation you want, say this, u will be equivalent to what we would consider x. So you have this as u. Now you can choose either one of these here to be the function. So we'll have u squared. Now this here will stay 0 if you want, or you can have v or t in order to do other things, but for right now we're going to keep it 0. Now for the domain of the variables here, we can have negative 10 to 10, but since we know the variable domain of x is 0 to 2, we're going to keep it like that. And now you have a kind of a function. Now you see it here, but to get a better visual, you can rotate your graph like so. So you have a better visual of what you're actually looking at. So also, if you wish to click here, you'll see the XY plane, you'll see the XZ plane, and this will be the YZ plane. So here you'll see a better identification of what we're looking at. So this is the function we did earlier, from all the way up here and then from this point on. So you can kind of imagine shading that in, and you'll have a somewhat triangle if you imagine a line right there. So now that we have rotated this, and we'll go back to a view so you can see it. Now, in order to kind of show what the 3D version of this would be, we can go and copy this function 3 separate times. And what we're going to do is simply click this edit button, change the U to a negative in one of those. Now you see what that did. We now have on the other side of the equation, so it's basically a parabola on one version of the plane. It's a parabola of the plane. So in order to see it better, you can also change the color. So now you can tell which was our original, which was not. Now, also to get a better visual, you can change which one has the U. So we're going to do that here. Now, when we look at it, you can see the 3D shape forming. Now, it's kind of difficult because you can't really see a shaded part, and it's really hard to shade. But if you continue changing the colors, ooh, that's too bright. Let's go to something a little bit darker. How about blue? Blue's good. So now you see that. And one more time. This time changing this to 0 and this to negative U. And then change the color if you want to something that's easier. Kind of different. So what we just saw for the equation was the volume of this shape. Now what you can do is kind of imagine connecting these points together and forming a little cyclone right there. And that would be the shape that you just solved. It's pretty impressive. I wish I could shade it in, and you actually can somewhat if you did using a snipping tool and paint and whatnot, and kind of mess with it a little bit. That's pretty much the point. You can also show where the points are on your graph. So for here, that's all the separate points, all the little tiny points, and you can change the size of them in order to see them better. Boom. Yeah. So you know, those are all the different points. That's whatever. And you can see down here the view, what it might be. You can change the appearance, so you can show the grid lines if you want, so you can kind of see how 3D it really is. It kind of hurts the eyes a little bit though, in my opinion, so I don't like them all that much. But this is how you would use the 3D graph. Now, like I said, it isn't really like solved in. You can't really color it in. You have to do that manually. But the point is to get a more visual picture of what you're looking at. So this is what you were trying to solve, was this visual revolution, this disc right here. Other than that, now the other method would be to use a washer, and a washer would include, if we were to get a new one. Now the washer method, if we use y equals x squared, and we also have the equation y equals square root of x, and first we'll solve where these two are equal. So where is, the square root of x equals x squared? There's only real 2 points, and that's at 0, 0, and 1, 1. So those are the only 2 points where these two will be equal. So the next step is to figure out which one goes on top, and that's important because the volume, when using the washer method, equals, and you can pull out the pi here if you want, the value of A to B of big R, big radius, squared, subtracted by the little radius squared. Now, the big radius, like I said, is usually the equation above, and the little r is the equation below. So for right now, you usually would graph that out in order to kind of show you what that would be. But for the terms of this purpose, we will know that this equals big R, and this equals, by default, little r. So when we substitute these back in, we'll get the volume equals pi from, since we know the x values, 0 to 1, of the square root of x squared, which is basically x, minus x squared again, which is x to the 4th, which we've solved previously. And then integrate. So when we integrate these, we have pi times x squared over 2 minus x to the 5th over 5 from the integrals of 0 to 1. Now, since you already know that 0 is going to be 0 for both of these, you can just skip that step and not even worry about the 0 value. But so we will have pi. So the answer will be pi times 1 over 2 minus 1 over 5. Which should be, when you find the common denominator, it's 10, which will be 5, which this will be 2. So the answer will be 3 pi over 5. Oh, I'm sorry, not 5, 10. That's why you should show your work, folks, because you'll make stupid mistakes like that. So 3 pi over 10. Not too bad. Now when we go over to the graph and try to show those, you can delete these, obviously. So we have the original graph we had here. You have that one, which is x squared. But if we add a new one, we'll choose this one to be u. And this one will have to be u. And you want to do the parentheses here. Like that. And you can see that would be what the graph would look like on that plane. So this is what it is, and if we can zoom in using the zoom tool, you pull your mouse back to zoom out, pull in to zoom in. So this is where this would be the area right here that we were trying to solve as we rotate it. So if we go back and rotate this, ooh, it's a little close. There we go. But so if we get a closer view like here, and we could do what we did before. Make 3 copies of each, and then change the variables. So this would be the end result of what you would get. And other than that, without, once again, using paint and all that, you'll be able to use that for to kind of see what you're really working with. Anyway, that's all the time I have for today. You can also change, edit the domain of the variables in order to get a better looking graph. So I hope this video was informative, and if you have questions, feel free to leave comments.